Okay, so let me make sure I can see everything on the screen so I remember what I'm talking about. Okay, well, it is my pleasure to be here today to talk to you about using technology more specifically with a laying hen focus, because I knew Marion would really cover the broilers well based on what her previous work has been done. And I'm going to think about it a bit more from the practical perspective of what is maybe going on in the hen house. So, where I'm going to take you today is we'll set the stage a little bit for what I'm going to talk about with respect to technology. We will dive into just a little bit of the research in terms of what's under development because, as Marion said, there seems to be a study a minute coming out with respect to using technology in poultry spaces. And then we'll talk about what's actually translated into the market, first for large egg producers, but then also we'll go into kind of that backyard and small producer space as well. And then we'll wrap up with some key takeaways. So, to get us started, probably when you think about technology in the hen house, there's something that pops into your mind, right? I know there certainly is for me, and it might look kind of like Rosie the Riveter robot from the Jetsons. Um, and I'm sure many of you haven't really conjured up this vision. This is a chicken wearing a virtual reality headset. And I'm not sure if this is an AI generated image, but I do know that there has been some work in this space, and not just with chickens, but with dairy cattle and other species, where there's this idea that rather than maybe modifying the housing system of these animals, we can create virtual reality for them so they actually think they have outdoor or free range access. Okay, so this is maybe the very futuristic version of technology in the hen house. But then there's also, of course, kind of the research context, right? And there's certainly a lot of space for developing technology that we can use to answer important questions, um, such as, why do hens lay on the floor? So if we can kind of do some more triggering or research that's kind of aimed at getting to root causes and motivations and to understanding the development of problems or the connection between underlying physiology and then resulting welfare changes, then perhaps we can actually scale up in a different way as we take that information to commercial industry. Right. So there is a ton of research going on, and I'll show a few additional examples in a minute. But the point I want to make here is that a lot of the things that are really under development now may not be scalable for actual everyday use on farm, but that doesn't necessarily mean that they're useless, right? They can really lead us to some key insights in understanding our birds better, and then we can use that information in a more commercial setting. So when we think then about translating it to the farm itself, you think about the modern laying hen facility, which is really a very technological kind of place, even when we just think about automating water lines or feed belts or manure belts. So there's simply a lot of technology in there, even if it uses rather mm, traditional kinds of methods, right? Like conveyor belts or timers or thermostats. That's still technology and it's still incredibly useful in making farming more efficient. On the small scale side, we're starting to see things that help people with their backyard flocks or small coops have more control at their fingertips so that perhaps when they go off to work, they can make sure that their chickens get out for the day from the coop without having to maybe run out into the pasture to open the door themselves. So there are some different things ranging from these big commercial applications where thousands or millions of hens are experiencing technology to backyard flocks where you might have a handful of hens that are experiencing technology. So really where we're going to spend most of our time today is this on-farm technology space. But I do, as a researcher, of course, spend a lot of time both myself engaging in research for laying hens, but also in reading about all of these crazy things that are coming down the pipeline. And it's sometimes really difficult to keep up with all of the developments that are happening. So here's a couple. Most of what I've picked here is very recent stuff, so within the last year or even 6 months, where we're talking about all of these different ways where we can use either computer vision, as are in the top case here, where you're actually looking at these chickens and you're trying to track their body movements, and then you're trying to figure out how this movement is translating into their use of space, for example. And then, of course, a lot of where the time consuming part of this is still on the research side is relating all of this data that we can get quite quickly from cameras or from sensors, but then connecting it to ground truth, right? Is this actually accurate data? And Marion phrased it beautifully with the garbage in, garbage out, right? If you don't test this to make sure that it's telling you what you think it's telling you, then you really have no idea if all of these then models and algorithms and predictions that you develop afterwards are actually any good. Or another key part from stepping from these research studies to a bigger scale application is, are things generalizable? And that's something to really ask yourself as you're, if you're doing any of this reading yourself or seeing kind of the more public media space articles in like Feedstuffs or Poultry World or things like that, where they're talking about this amazing technology, but perhaps it was only done on a handful of hens and maybe of one specific breed and one specific housing type. And so will it translate, right? So those are always some questions to think about as you see these potential emerging technologies and really whether or not they have any future potential. So the one at the top here is definitely a very technologically driven kind of use of computer vision. The one at the bottom, though, is an interesting one because it's talking about this potential, really maybe emerging space where the tech could perhaps be applied in a low cost way to help small family poultry farms. And we're talking maybe 100 to 1,000 or a couple thousand birds, where you really want to get a sense of um, what these hens are doing in terms of how many eggs they're laying. And this is a very small farm indeed, where you only have like 2 nest boxes, and you're trying to figure out how many visits each nest box is getting per hour or per day, and how that's translating into your laying performance. And so here you can see maybe that one of these boxes is being used more than another. But this is an interesting space to think about because there are a lot of people who have backyard flocks, or there are a lot of people in other parts of the world, or actually even in the US or Canada, where you might be combining farming with another job, right? And so you're not home all day to watch your chickens, but you still want to make sure that they're well cared for and that things are going to plan. So is there kind of easy technology that we can develop in a low cost way for those small scale settings? So, some other things that are under development involve the use of sensors or individual animal tracking. And so these studies here represent the use of actual body worn devices by the animals, in some cases, just simple tags that allow you to is a real challenge when it comes to doing animal welfare or individual monitoring on the farm is that we have lots of birds, often densely packed together, and they all look very, very similar because they're coming from one genetic strain, which has been highly selected. And so they're quite homogeneous. So, are there simple ways that we can tell them apart? And could it be as something as simple as a printed tag? Or can we use other kinds of sensors like RFID type sensors that provide both information to a base station, but then may also record things like acceleration on the tag itself, which can be decoded into giving us cues into their different kinds of behaviors. But again, if you have to tag each individual bird and then recover that tag later, you're thinking about both manual labor and potentially about the cost of these things as you think about scaling up. So, is this technology that's maybe useful in a research space? Could it maybe be a sentinel population of birds that are monitored this way on a larger farm? So then maybe we have more detailed welfare information around the clock and more continuously, but maybe not for every hen. Or is this something that could be translated into a backyard flock, for example, or a small scale flock? This is an example of some work that I've participated in with some colleagues from MSU and Clemson, where we're actually trying to use some technology to not only detect problems, but then also to intervene. In this case, my colleague Daniel Morris had developed a process for identifying piling and laying hens. And you can see kind of a pile forming in the upper left corner of this image here. And once the computer system detected this LED array along the wall would then generate a flashing pattern in order to try and disrupt the piling behavior. Now, of course, when you do something like this, it's a delicate balance between disrupting the pile, causing panic, or having the hens habituate and then ignoring the lighting. So initially, we did some testing to figure out how intense the lighting could be, whether there were colors that would affect the hens more strongly, so that we didn't cause a panic. But then we had to do some different work to figure out how quickly they habituated. And what you can see in this bottom graph here is that initially, for a period of maybe 4 days with some of the patterns, but maybe only 1 day with other patterns, you would get a reaction from the hens. And then that reaction kind of diminished over time, where it would go from a large reaction to a small reaction to then almost no reaction at all. So you have to think about the fact that these are living animals that learn, and they can start to, over time, recognize when something doesn't actually pose a threat and then begin to ignore it and focus on other stimuli instead, right? Of course, another thing that you have to encounter when you're mounting technology at this type of a level in the barn is whether or not the chickens are going to physically interact with it, right? And this, of course, is something that probably many of my colleagues on this call have experienced, right? That you have chickens interacting with your devices in unintended ways. And Daniel and Yunfei initially had not really prepared themselves for the fact that the chickens were going to pull on all their cords, they were going to peck on the lighting array, and often the LED array would end up on the floor initially until they really learned to adapt and to modify their structures for attaching it to the wall and for protecting the devices and the cords. So those are some other things, that we commonly have to think about when we're using technology on a farm, is whether or not it can withstand the birds and their environment, which often involves a lot of dust as well as maybe moisture, ammonia, CO2, other things that are very harsh on sensitive equipment. Here's an example of a robot being used in a poultry house. Now, this is being used in a cage laying facility, and this is an inspection robot. And so the idea is that you run this robot up and down the rows in these cages, and you have cameras at all these different levels. And what they're really looking for here is mortality in these cages. And then you send a human in to remove it. So this is really only a partial automation, right? It can certainly cut down on the amount of time a human needs to spend in the house, climbing up and down sometimes to see all of these different levels when we're stacking these cages, sometimes 4 levels high above and 4 levels below a floor. So of course that can save a human a lot of time and maybe a lot of repetitive strain injury, and then just target their attention to going in and doing the removal of the problems. But of course, we have a lot of facilities around the world that are moving away from cages, which might be simpler to monitor, into more complicated cage-free environments. So again, we have to think about the fact that this might not translate into housing systems that are becoming or coming down the line in future. Okay, so another project that I'm currently involved with my colleague Ahmed Ali at Clemson is the idea of looking at automated technology to disrupt a common problem as we move to cage-free systems, which is floor laying. And of course, there have been some attempts at commercial designs on the market, and other colleagues working in the space, such as at Georgia Tech, thinking about whether or not robots can be used with poultry. Most often, though, they've worked with broilers or kind of open pen barn systems. So here we have a system that we've developed to see whether or not robots could disrupt floor laying. Do they compare to a person walking the house, right, and trying to get the birds to move back into the system? And then does the kind of aviary design that we're using these in affect how well they work? So here we have our little robot that's been developed. And then here we have maybe what actually happened. Apologies if that's a little bit loud there. So what you notice is that the chickens quickly acclimate to the robot, even when it's moving, and they like to use it for rides. And so we actually saw not only the chickens riding on the robots, but roosting on it regularly, sometimes so many of them that the robot couldn't move. And then they also liked to lay eggs on and around it because it created little kind of niches. And you can see where it stopped in this video up here. There's a hen behind it. So she's got like a little corner space that makes quite a nice little nest area for laying an egg. But we did actually find eggs on the robot itself, right? So there might be unintended consequences when you did this. And in the end, we decided that really these robots were actually more effective as enrichment for the hens rather than perhaps deterrence to floor laying. And some of our initial data suggests that in the pens with the robots, we actually had a bigger floor laying problem, and that certainly did interact with system to make things worse in some cases. All right, so now let's move into the next phase of our talk here, where we're going to talk about what do we actually have on large scale poultry farms. And so by large scale here, I mean tens of thousands of birds up to, in the US, in some cases, millions of birds on a single farm. So there's certainly a lot that we have in hen houses. And I mentioned at the beginning that for as long as we've been bringing hens indoors, we have been automated feeding and watering, right, by using gravity controlled feeders or nipple drinkers on water lines. We've installed belts under cages and under tiers in aviaries to automate manure removal. We've automated ventilation, right? So you have a thermostat that triggers the fans to come on when it gets too hot. And then, of course, we have automated measures of temperature. And I just realized that I forgot to put the very biggest one of all on here, which is automated egg belts, right? We have eggs rolling out onto belts, and then those belts roll, and then they not only collect the eggs from each cage, but then they also take those eggs from each house into a central facility where they can be checked, cleaned, packaged, or broken, depending on the type of facility we have going on. So there's a whole lot that's going on in houses already, right? And of course, in some cases, we're using um, scales or water meters or timers or thermostats to control a lot of what's going on here. What's really changing now is that a lot of this data can now be captured and viewed remotely, whether it's on control panels or on phone apps. Some of this data is being more integrated, right? Where we have not only temperature, but then maybe also humidity or carbon dioxide meters coming together to say, yep, the air quality is not great. We need to do something about it, not just maybe from a cooling perspective, but from an air freshening perspective. So there are different kinds of timing happening. If you'll excuse me for a second, I have a cat who's just been through surgery that I have to pick up and put on my lap because she can't jump there. She's very determined. Okay, back to the chickens. So we're seeing, some of these processes that have been routinely automated that we're now actually doing a better job of enabling remote monitoring to detect maybe leaks in water lines, blockages in the feed, assess whether or not there's everything's gone to plan, and then also be able to look at this remotely so that you don't have to necessarily be in the house at the control panel to see all of this happening, and that you can even get alerts to detect when things might go awry early, right? Certainly, if your birds start to go without water, you want to know that sooner rather than later. Or if suddenly you have hens decrease the feeding that they're doing in a barn, why is that happening? Is something going wrong related to the tech, or is it related to the birds themselves? So there is a lot that is currently in houses. And this is an example of an integrated control system from a company called Prism, used to be PMSI, where they bring all of this together into these common modules, right? And so this is also something that can make the tech more useful for a producer. Marion mentioned cost being a big one, but I think also the ease of use and integrating new kinds of technology with existing systems is also important. No producer wants 40 or 50 apps on their phone, one for this, one for that, each one that has a different interface and a different way of working, and God forbid, a different login and two-factor authentication, right? So it has to be easy to use. It has to maybe be something that they already know and understand and trust in order to make that barrier to adoption and learning easier as well, right? Because that's certainly real. I just set up a lawn robot over the past couple weeks, and let me tell you, I waited for a week or two until I had like an entire day that I could sit there and mess around with things, right, to get that right. So when you have a company that maybe slowly keeps adding different modules and it's a company you know and trust and maybe also know the tech representative in your area and you have good rapport with customer service and know you're going to get customer service, that I think is also important for producers, right? That practicality of it being usable and not, not just cost effective, but also something that makes sense and that they can do. So what you can see here when you're looking at this PMSI or PRISM data, right, is that there's a lot of different stuff that it's monitoring, and then also a lot of stuff that it controls remotely, right? So it's one thing to be able to see what's happening, and then it's also another to be able to maybe adjust and do something about it, particularly if you have an emergency and you need to be able to deal with something right away, right? And if you can do that from a remote app or from this control panel, in addition to having to go into a house. And in the US, these laying hen barns can be 400 meters long, right? So it is not a simple endeavor to get into the barn, find the problem, get all the right equipment into that space. And if you can figure out exactly where the problem is happening, what you need to take with you before you go, that helps, right? So there's a lot that's going on here. So one of the things that we're starting to see claims about is that these kinds of tech and the sensors are actually monitoring the birds themselves. And I've highlighted this producer quote from Vencomatic and their Megsius system, right, which is also a very integrated control and command kind of system. And this producer from Canada says that they can monitor the behavior of chickens in the barn. And look at actually their behavior and what areas they're avoiding and why. And he says that this is really valuable to him because they want to learn more about the chickens themselves in order to farm better. So for me as a behavior and welfare person, I love that he's thinking about this at the level of the bird and how the chickens are actually doing in the system, how they're using the system, and thinking about it from their perspective. But then I immediately started to question, well, is this system actually monitoring the chickens? Because I have gone through my fair share of technology websites who say that they're doing this. And at the end of the day, you find out that they're maybe monitoring whether or not there's water being used in a line or water flowing through a line. And you don't always know if that means the birds are drinking it or if there's a leak, right? So I delved deeper into this. And they have some really lovely videos on the Vencomatic site. I'm not promoting necessarily whether or not Vencomatic actually works. I don't actually know, haven't talked to somebody directly, but they do have some very nice videos. And one of the things that they show is kind of this walking through how some of the different data that's being collected and shared with the producer can be used to try and determine what's happening in the barn. So the first thing they pop up here is this data on where the eggs are being laid. And so what you can see here is the percent of eggs that are being laid in each row in this open aviary house, right? And so what you see at a glance is it's not an even distribution, right? Those two rows at the sides are seeing a lot less egg laying, right? So it looks like the two in the middle, lots of hens laying there, but the two at the edges, they're considerably lower. Well, why is this? What I do want to point out here too is that you can also see this by tier. So this is really detailed, right? You're not only seeing which row in the house, but also whether the hens maybe are laying differently based on level. And the top level here, I also want to point out these are just system eggs that are appearing here. There's no actual nest box, but they are still rolling out and being collected by a belt. So here we have some dedicated nest boxes in the bottom two levels where you'd expect to see most of the laying, and then of course some system eggs. Okay, so we have this data on where the hens are laying their eggs. We see that it's off kilter. It maybe should be 25, 25, 25, 25 in an ideal world, right? Don't want the hens crowded. This next graph then highlights the temperature in the barn, where the red is the warmer temperatures and the blue is cooler. So their diagnosis here is that because these outer two rows are colder, that the hens are avoiding them, and instead they're clustering in those center rows for warmth, and that happens to be then where they're laying more of their eggs. So this then could trigger the producer to, all right, do I have something going wrong with my heaters? Do I need to turn the heaters on at a lower temperature? Am I going to need to install maybe more of a system to actually help mitigate this and then spread out the egg laying, right? So they can diagnose whether it's a problem with their existing technology or maybe whether something new is needed in order to get the hens to lay more uniformly. So there's one example. So here's another example where we're looking at some measures that are actually being taken from the eggs once they actually get into the egg processing and grading part of the system, where you can see the change in this line where you've got this really nice graph in egg volume here, and all of a sudden it starts to taper off. And so the producer at day 31 of January decided to, as they're eyeballing it, they think, oh, that's not right. I'm going to call the vet. So they call the vet, and then the vet basically comes out the next day and they diagnose a Clostridium infection. And what Megsius is saying is that you can actually look at this data in a more automated way and detect that departure from normal expected egg volume much earlier. And that when you integrate this data with other things like changes in feed consumption or water use, or maybe other parameters that are going on in the system, you can actually get this kind of early warning, right? That something is about to happen. And Marion had pointed that out too with the OptiFlow data, that sometimes you can use this tracking as you're going along, and once you kind of get the sense of what these patterns mean, you can predict earlier in that pattern change that something is going to happen. And can you step in and intervene, or step in and bring a vet and get a definitive diagnosis on what's going on and get that treatment going earlier before it spreads further? So this is a way, right, where we're not using necessarily fancier sensors in these houses, really. We're using a lot of standard production parameters, a lot of standard kinds of metrics that we take in order to keep the hens alive and healthy, right? Feed use, water use, temperature, but we can use this data in a more integrated way. So what happens then when we think about the direct monitoring of the hens themselves, right? Whether we're using computer vision, remote kinds of sensing things like microphones to detect their sounds, or whether we're tagging them. Well, when we're talking about a laying hen barn, and you might remember from that diagram, some of the diagrams I've shown earlier, we've got a lot of tiered structure in these cage-free aviaries. You simply cannot see around a lot of these barriers, or even if you install cameras in a lot of spaces, the hens that are closest to the camera might block your view of deeper into the system. Certainly, the nests are very difficult to see in. So computer vision is difficult, and you'd need a ton of cameras, which would also cause its own issues of maybe workers on camera, privacy concerns. How do you store and process massive amounts of data from a laying hen facility, right? There are some solutions to that, but they might be heavier solutions than are cost effective or labor effective right now. Another idea, right, is leg tags, or RFID tags in some way, shape, or form, right? And these are certainly getting dramatically cheaper so that they aren't more expensive now than the cost of the bird itself. So these passive tags that are developed, clip on the bird's leg, and then they get read by sensors at various points in the barn. And you could maybe tell, if you have chickens that are using the nests, using all the nests, if this chicken is visiting the nest on a regular basis, for example. And there's also the ability now to print and recycle RFID kinds of tags, right? So you don't necessarily have to buy a tag, but you could buy or print these little tags and then attach them to something that you already have. So there's a lot of movement in this space that's maybe making this more feasible. But still, when we're talking about tens of thousands or millions of hens, individual attachment of devices to birds is a complex endeavor. And of course, ultimately, when these birds, maybe depopulated at the end of lay, you don't want these tags going either into compost or into the food supply. Okay, so what other kinds of tech are there maybe for getting a better handle on our birds themselves? There's definitely some advances in terms of in-barn weigh scales. And I've highlighted this one because this is one that could actually be used either in a tiered aviary kind of system or in cages for laying hens, where the bird hops onto this little perch-like device and it gives you a weight. Now, these birds aren't tagged, so what you're doing is getting weights of maybe a lot of birds in the flock. Maybe sometimes the same chicken is going to hop on more than once. Maybe some other chickens will never hop on. But you can get enough of a sense of the ideas of weight to generate some information about, what's the weight uniformity of your flock. If these are pullets that have just come in, are they growing? Are they hitting mature body weights on target as you'd expect for their breed? And then maybe you could get some information also about feed efficiency. So if you're looking at weight and you're coupling that with feed usage and egg production, you could get some really great metrics about hen weight versus how much feed is going into her weight versus into the eggs, and whether or not all of those metrics are playing out as you'd expect. And of course, if you've got birds maybe in more of a litter-based system, or if you have litter areas that are easier to collect weights in, there are other scales similar to those that we've seen more regularly in broiler or turkey barns that can also be used with laying hens. Okay, so we can get some body weight information from hens, maybe more on a flock level basis than on an individual bird basis, but it could still give you some useful information directly from the birds themselves. So shifting gears a little bit, another way that technology can be used in the barn is to maybe automate some enrichment, right? There's growing maybe requirements for enrichment for some countries' legislation or for certain producer types of certifications. And so this is an example of an enrichment developed by Big Dutchman called I think it's the pick puck, where it drops feed down on this peck stone. And so then the chickens both get their beaks kind of trimmed, as it were, as at the same time they're getting some supplemental food sources. Now, one thing that we have to ask ourselves is whether or not this translates into outcomes. This is a point source enrichment, and if it's not provided at a high enough rate within this flock, you might end up with competition, or perhaps only the high status birds are going to be able to access it, right? Because the lower status birds are going to have to kind of fight for access to it in a densely stocked aviary situation. And then, of course, thinking about whether or not it translates into actual well outcomes. Do we see better feather score, for example? Do we see less pecking damage because the beaks are less sharp? Does this help with flocks that don't have beak trimming, or where there might be a breed that might be have a higher propensity for feather pecking or cannibalism? So those questions will be important in terms of thinking about what uptake will be like. Okay, another angle to think about is robots, right? And certainly there are videos that you can find on YouTube, and there's lots of articles that appear in different kind of lay publications or blogs or podcasts, right? Talking about this idea of robots moving through the house to collect data at the hen level, or potentially to do things like reduce floor eggs, or maybe it's really to manage the litter by turning it over and making sure that it's dry and aerated, right? So maybe there's some potential, and this is one that's by T-Bot that was recently taken over by Octopus, that is supposed to be able to work with all kinds of different poultry species and with egg layers, right? They claim that it's going to result in fewer floor eggs, and in a broiler breeder flock, maybe higher fertility and improved feed conversion and average daily gain, right? So those are some interesting claims to make, and be interesting to see if these become taken up more widely, how producers feel about those translating. Other kinds of robots, maybe are less in the space with the birds themselves, but might be also useful in terms of producers' ability to automate unpleasant tasks, right? This might free up humans to do other things, which might result in retention of farm labor or maybe less employee injuries or hearing damage as they do things like as they walk away from pressure washing or other kinds of tasks that are, not really pleasant to do. If you've ever had to do them, they're not a whole lot of fun. So maybe robotics in this space will prove useful, in the more near term. Um, One thing to think about though is as I was doing some research for this, I kept finding a lot of broken links, right? I'd find like a news article or a blog on a promising robot, and then I'd try to follow the link to the robot page itself. And a lot of cases it was I got that 404 file not found kind of message. And an example of that is this proposed robot from Big Dutchman. And the last I've seen of it was in 2021. This was Barney, the barn robot that was supposed to run on the floor. And I'm not sure if it ever panned out. The beta version may never have gone past a beta. And this is something that's commonly seen with a lot of maybe startups, is that there's like this promising development, then maybe they get bought out and integrated into something bigger, but maybe it just doesn't actually work when you're trying to scale it up for some of the systems that they're initially intended for. This kind of ties back to a question that was actually raised following Marion's talk about using tech to maybe improve breeding, right? And a lot of the genetic companies actually do have an interest in using technology to collect more phenotypic data, especially for cage-free laying hens, because typically when hens were housed in single cages, you had a lot less to worry about in terms of what was going to make them a good layer and how that was going to translate into cages on a farm. Well, now that we're turning chickens loose into these bigger groups, you can't select them on an individual cage bird basis because the parameters you're selecting on might not be the ones that make them successful in that group environment. But it is really tricky to collect a lot of behavioral phenotypic data, right? You have to watch a lot of video. You have to be able to track a hen individually to know how this particular breeding animal is going to do and how that behavior is linked to their underlying genetics. So companies like Hendrix have been really getting into this space and partnering with universities or developing in-house proprietary tech that allows them, for example, to track which individual hen laid that individual egg and also how she's doing in that cage-free environment, right? Is she still a good layer when she's maybe having to compete with other birds for nest space or for roosts at night? Is she a hen who's getting picked on, or is she a feather pecker? And so they're trying to collect data about those type of things, as well as things like keel damage, and then figure out, how that translates into their breeding programs and their selection indexes. So there's definitely some work in this space. All right, so now I want to move into something that I found very fun, and I kept getting distracted as I was making this talk by all of these little proposed tech available for your backyard chicken. So, in some ways, some of the stuff I've been talking about, right? I've been talking about problems of scale, where when you're trying to move a piece of technology from a little research setting into with a flock of maybe tens or hundred into barns of thousands and millions, how do you do that? So maybe sometimes there's actually a market for some of this tech to stay at the smaller scale, and maybe this is actually more feasible and maybe more useful. So there are some prefab coops that are out there that have this technology that they come equipped with. This is the Smart Coop, and it comes equipped with an app called Eggstein AI, and this has all kinds of touted features like detecting eggs on the floor. It can identify all kinds of different predators in your coop. When it identifies a predator, it'll send you an SOS. Then you can close the barn door or set off a barking dog sound or flashing lights. It'll tell you if all your chickens have come in for the night. It can individually identify all of your birds. And it has a cluck talk feature, which will supposedly, right, identify all of your chicken vocalizations. So it's supposed to be like super fantastic for, knowing everything about your chickens and keeping track of them. Um, Now, there are fairly few, I would say, disinterested reviews about a lot of these products. So I'm going to preface, these products by saying I don't have any working knowledge of them. But of course, you can see here that this is kind of a prefab out of plastic situation. One comment has been that, it doesn't come with any temperature monitor or ventilation control. Other people have noted that it's designed for 4 to 6 birds, but it doesn't really fit large breed hens very well. Silkies and bantams would be great in here, but if you've got some big chunky Aracanas, maybe not so much. And some people have commented their bigger body birds block the cameras and don't like going into the nests in this system. Here's another one. This is the run chicken system. And it's made out of these kind of fancy panels that you slide together to create this very modernistic looking coop. And it's got these doors that slide up and down that are solar paneled. And of course, it's got an app that controls things as well. It's got a really fancy feeder that is actually designed to, in theory, be pest proof, right? So only your chickens are eating the feed and not your average mouse or rat that might get into the building. And it's supposed to be highly cleanable and easy to maintain. But again, this is quite a small coop. You can see the size of the ladder versus the size of the space maybe for the outdoor run. So whether or not this would fit a backyard flock of more than a couple of birds, right? Maybe not. Um, Okay, so maybe some of those prefab coops themselves might have their limitations, right? Maybe they really are only more for the pet chicken enthusiast and have limitations in terms of cost. Some of these range from $1,000 to $2,000, right? Which is a lot when you're thinking about them just housing 2 to 4 to 6 birds, right? Um, but if you're maybe more interested in using a bigger, maybe wooden, more traditional style coop with a bigger run, you could still add some tech to your coop, right? And there's certainly a ton of automated doors on the market. Many of them are solar powered. Lots of them have apps to tell you if they're working or not. All kinds of different companies, manufacturers, types of materials, aesthetics. So you could really almost plug and play with anything that you'd like. One cool thing that I came across too was this idea of a customized solution where, in this case, Radio Force was contacted by a small organic grower who wanted to know which chicken was laying how many eggs. And so they put some of that RFID technology into action and tagged all their hens and outfitted the nests with RFID readers and really got a sense for this producer of which of their chickens were the productive girls and who was having problems, etc. So certainly not a cheap solution. It was very, very customized, but maybe for this particular producer, it was worth it, and especially if they could reuse it over multiple flocks. There is some stuff that's available for these kind of this growing range of mobile hen coops, right? And so this kind of niche market of pasture raised or maybe organic or high welfare kind of flock that's the small scale flock, maybe sold locally at a grocery store or farmer's market or direct sales, right? And a lot of these come with varying degrees of automation and monitoring, remote control. Lots of them are solar and battery operated, so power's not an issue. And of course, they have some very fancy features like manure belts and roll out eggs and fans and lights and doors that open and close in an automated fashion. But again, a lot of these are in fairly early stages. How long some of these brands will persist in the market is something that remains to be seen. And then one of my favorites was coming across some of the DIY kind of automation here, where in addition to those kind of prefab ones, where people were piecing together all of these different components, right? So somebody might have started with a smart coop, and then they added a temperature monitor to trigger fans, a water sensor to monitor them on how much their hens were drinking and when to refill the tank, put a motion sensor at the bottom of the feeder so that when the feed disappeared, you could see the hens moving and you knew you needed to add more. And you could connect these to different kinds of control hubs that are made for human homes. So there's a lot of really creative people out there that really get into their tech and their automation for their laying hens. And this person that I pulled up this example from He actually developed a whole RFID tag system that had each of his hens labeled and was tracking who laid in which nest box when, trying to really get an idea of, how often his birds were visiting the nest. Go to this website, you'll even find the open source coding that he provided for doing all this stuff. So here we have an engineer with a chicken fetish, right? With a little too much time on their hands, but all kinds of stuff. Okay, so to wrap up, our key takeaways here then are that commercial laying hen farms, right? They've got a lot of existing tech, and a lot of people are starting to figure out ways to make better use of it, right? So to take all those separate data streams, to integrate them, and then get some actionable information, or to turn them into integrated control platforms or applications where you can do a lot of remote monitoring and control. On the small scale side, everything, we've seen everything from prefab kits to tech add-ons to DIY. And so you can really customize what you want to do with your backyard girls or with your small flock and really think about what kinds of things you need to know or optimize for your system. But it's definitely, innovations are coming and going at a pretty rapid rate, right? Every day there's something new, and every day something doesn't make it and goes away. So trying to figure out what's going to stick is a little bit of a dice rolling proposition right now. So if you're thinking about doing this or advising somebody about what to do, it's really key to consider what the goals are. What do you really need? What do you want this tech to do for you? Are you missing information or a certain kind of control that you need, or maybe the ability for you to do this remote stuff so you don't feel bad leaving home with your chickens at home? And then do your research. And then once you've gotten to that point, then you're kind of in a better place going forward. So that is what I have for everybody for me. And now I am happy to go into the next phase and take questions.
Thank you so much for the excellent talk, Dr. Siegford. Um, I definitely appreciated the scope of all of the technology you just provided to us. But do you find any differences in like the willingness to integrate between, say, the backyard producer versus commercial scales?
I would say in both of those groups, you have people who like to stick with simple, no frills, gravity fed things, simple thermostats, um, less to break, right? Kind of things. Like there's kind of two approaches, right? Less input, but then also less maintenance and less worry, all the way up to people who, man, if they can automate it and put a bell and a whistle on it, they will do so, and they will be on their phone monitoring their chickens 24/7. So I think there's a range of people in both of those spaces. And so I think that's why it's so important to consider, what are you hoping to get, or what do you need? And is there something simple that you could do that would stress you out less? Or do you really want all that tech so you can get every single insight about each chicken heartbeat, right?
Mm.
So yeah.
Great. Um, so you showed the amazing video of the chickens riding the robot, and we know that laying hens often have an innate fear of humans, which doesn't often lead to the same kind of habituation. So do you think that using robots could actually be better for the welfare of the hens in terms of we're not disturbing them as humans as much?
Yeah, I guess it depends a little bit, right? There's two thoughts on that. Some people think we should stay out of the house as much as possible and not freak them out, but other people think we should be in there a lot so that they are more used to us. And that's one of those dangers with technology is, do we end up then kind of giving up our responsibility in terms of caregiving by not being physically present? So I would think that it would need to be a balance a bit, and actually those brown birds that we showed riding the robots, they rode us as well. They would fly down and perch on us. So these girls might not be the best example of chickens that have fear. They
Mhm.
certainly approached us as willingly as they would the robot, and it was equally as hard for us to walk through that house as it was for the robot. But thinking about maybe the features of the robot, whether you have a legged robot versus a wheeled robot, or whether it's a robot that's attached to the ceiling or the wall and moves on a track, or whether it's even a drone in some cases, right?
Mhm.
What you are trying to do with the robot, whether you're trying to monitor them in an undisturbed way versus trying to get them to move, could think about, right, what features you accentuate or minimize. speed, unpredictability, sound, light, other things versus just this is how the robot goes every day and everybody can be mellow and ignore it. So I think it really it depends, right? So what's your function and your aim with the robot?
Mhm. So we had some interest in the using the LED lights to avoid piling behavior. So we know that the common practice for this is electric shock lines, which as welfare people, we are not um, as as happy with as we could be. Um, do you think that the LED lights are as like has a good effectiveness as the using an electric shock line? Have you done any sort of comparisons of this?
No, we haven't. But one thing I would think is that the electric shock line is going to be more localized, right? Whereas the light might travel further. And I know I've had colleagues that have tried to use the light to actually scare the birds into moving up into the house. And initially, the effect is more widespread than you want, and it causes maybe more panic and movement in directions that you don't think, but then they habituate to it. And so I think, with the shock, you've got more localization and probably less ability to habituate. So I think we're still kind of working out the balance in terms of, do we need to use that light in a more directed fashion to keep it local? And then do we need to vary the color and the intensity and the pattern and do it randomly to avoid the habituation? So I think it might be less aversive in the long run, but then thinking about how we get it to do what we want in that targeted fashion effectively. Yeah. Different problems that we have with that one versus the line.
So you've kind of already answered my follow-up, which was to do with whether you've looked at different light colors or wavelengths or flickers or
We
intensities.
haven't we haven't in full yet. We've really just done a little bit in terms of so with that LED strip we could do different colors, but we haven't played so much with intensity yet, for example. And then we're actually starting to do some look now at patterns that attract versus patterns that repel. Because we're also thinking, well, is there a way to stimulate movement or to have it be enriching, maybe almost from a worm running perspective or a foraging perspective? Of course, if we do that, we're going to have to bulletproof the casing because they're going to peck on it or try to pull it up. So my engineering colleagues are not quite ready for that step yet, I will admit. Yeah.
So we'll just wrap this up with one final question. Um, do you think there's any specific promising behavior which can be used as sort of a welfare indicator that people should focus on when it comes to trying to identify um, welfare concerns in these huge cage-free systems where things are hidden?
It is really tough. I actually have a grad student who's working on Play right now, because Play it's in the Poultry Welfare Quality Assessment Guide, for example, as an indicator of positive welfare for use in laying hens. But what we've suspected and what she kind of is starting to show is that as the birds age, after they get past that pullet phase, they don't really play anymore. So play would be one that we'd often think of automatically, but we might have to instead do something more like preening or wing flapping instead as kind of a comfort behavior, showing like physical ability to stretch, maybe with the wing flapping and the space to do so, or preening in terms of kind of that maintenance behavior that birds do. Now, there's always a difficulty in are they preening to compensate or as a redirected stress behavior? So there's always a little bit of that. There's not usually a magic bullet for one behavior that has an unequivocal meaning that is only positive, right? So I think we have to think about the context and whether or not there are any preceding or subsequent factors we can look at to kind of see what's going on. But so, yeah, no silver bullet for you. Sorry.
Well, that's great. Thank you so much for your time today, Dr. Sigford. And thank you for your questions, everyone.